The last section here is on dilations. Dilations. If you ever go to the eye doctor and you get your eyes dilated, what it does is it changes the size of your pupils, right? It makes them bigger and lets more light in so they can check your eyes. Kind of makes it hard a few hours after your eyes are dilated. But a dilation is basically a change in size. And what happens is when you dilate it, you're going to have an image that is similar to the original. So we're going to learn a lot more about similar in Chapter 7, but what similar means is that all the corresponding angles are congruent and all the corresponding sides are proportional. We'll talk about what that means. Corresponding angles congruent, corresponding sides proportional. When the image is smaller than the original, it's a reduction. When the image is bigger, it's an enlargement. So I think a lot about taking a picture and enlarging it, right? If you take a picture and you get it in a bigger size, it's still the same picture. All the proportions are the same. It's just a bigger version. Or similarly, if you get a wallet size of a picture, you just make that picture smaller. Or here we have these two tigers, right? The original tiger is here, and then the dilation is an enlargement, in this case, of a bigger tiger. Instead of tigers, we're going to do triangles. So we'll have an original triangle here. The original always has the plain letters, and then the changed triangle will have the prime, E prime, F prime, G prime. It'll have the changed ones. Or what we see here is we see the pink triangle here, ABC, and we see the ordered pairs that go with that. And then we see A prime, B prime, C prime, and then the ordered pairs that go with that. Can you see the relationship between those two sets of ordered pairs? -2 becomes -4, -4. 1, -1 becomes 2, -2. 0, 2 becomes 0, 4. What do you notice? Right, this is 2 times as big, right? Twice as big. Or what we'll say is that the scale factor is 2, right? The blue triangle is double the pink triangle. So we have a little formula, and it seems weird, but this is what it is. CP prime over CP. This is what is going to tell you if it's a reduction or an enlargement. It's going to really be the scale factor. So they have an external point, which is C, and then it kind of goes to P prime, and then C to P. So we'll get into the actual numbers. I guess this one in the beginning is just saying, is it a reduction or an enlargement? The original figure is in blue. So if I go from the blue one to the red one, is that reducing it or enlarging it? Reducing it, reduction. Here if I go from the blue, from the blue original to the red X prime, Y prime, Z prime, do you agree that that's an enlargement? That's all it is, reduction or enlargement. The blue is the original. PQR is the original, and then P prime, Q prime, R prime. So that's a reduction. Blue is the original. Here is PQR, and then P prime, Q prime, R prime. That one's an enlargement. So now we're going to get to that idea of how much did it reduce? How much did it enlarge? Where you're going to look at what's called the scale factor. Scale factor is the reduced ratio of a pair of corresponding sides. If it's less than 1, it's a reduction. And if it's bigger than 1, it's an enlargement. And here's where we're going to use that formula that we wrote up here. CP prime over CP. So the scale factor is CP prime over CP. Or if I look at my numbers, from C to P prime there is 2, and then from C to P is 3. So 2/3. So that's saying that it's a reduction. The red triangle, this red triangle, is 2/3 of the sides of the blue triangle. CP prime over CP. I like to write the formula every time. CP prime over CP. So here, C to P prime is 6 over 3. We always reduce it, so 2 over 1, or you could just say 2. The original is always blue. So what this scale factor of 2 is saying is that this red diamond is twice as big as the blue diamond. CP prime over CP, CP prime over CP. Here C to P prime is 12 over 3, so that reduces to 4. That's again saying that it's an enlargement. There's the original with the plain P. Here's the changed with the P prime. What that's saying is that the red square is 4 times as big as the blue square. CP prime over CP. This is going to be 7 over, be careful, C to P is actually 21, 7 plus 14, so it's 1/3. The original is the plain P, so there's the original triangle. The changed is the P prime. What that's saying is that the red triangle is 1/3 of the blue triangle. Now we're going to do a whole example where we have a picture. We're going to find the original coordinates, just reading them off the graph. So like M here is -2, 1. And N is 2, 1, 2, 3, 4, 2, 4. And L looks like 3, 0. You know, parentheses or no parentheses, right? Those are the original ordered pairs. Then it says K equals 2. In other words, take every ordered pair and double the x and double the y. So I'm going to take -2, 1 and double it. 2, 4 and double it. And 3, 0 and double it. Then I'm going to graph those doubled coordinates. So -4, and sometimes it goes off my graph. 1, 2, 3, 4, 1, 2. So the M prime is a little bit off the graph. 4, 8, 4, 1, 2, 3, 4, 5, 6, 7, 8 is one off there is the N prime. And then 6, 3, 4, 5, 6 is the L prime. And connect them. And what I've done is dilate that triangle to one that's twice as big by taking each ordered pair and doubling it. The next one is going to, again, take the original ordered pairs, so I'm just going to read them off of here. -2, 2 for G. H looks like 1, 2, 3, 4, 5, 6, 0, 6. I, 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 8, 5. And then J look like 6, 1. Taking each ordered pair, and then I'm going to follow what that tells me. It says K is a half. So every ordered pair, it wants me to cut each value in half. So -2, 2 becomes -1, 1. 0, 6 becomes 0, 3. Now when you cut things in half, it might be a decimal. Oops, 2.5. And then 6, 1 would be 3, 0.5, sorry. It doesn't like them at the bottom for some reason. So I'm going to have to write that one up here maybe, 3, 0.5. 0.5. So now I'm going to graph those new dilated coordinates. -1, 1 is the new G, G with the slash. 0, 3 is the new H with the slash. 4, 2.5, 1, 2, 3, 4, 2.5. This is the new I. J, 3, 1, or 3.5, 1, 2, 3.5. And there is the new J. And then if I connect it, I've got a parallelogram that's half of the original parallelogram. So this is dilation, change in size.